Okay, so we've decided the answer to question A here. The third harmonic is represented by this graph. So we're going to look at that graph a little bit more closely. So now we're going to determine the position of nodes and antinodes and eventually find the wavelength and vibration frequency of this particular wave. So the first thing we want to do is figure out the position of nodes and antinodes for the third harmonic, which we have pictured here. We know that the entire string length is 8 meters. So just from geometry, they know that if we divide this into 3 sections, so section 1 goes to here, section 2 goes to here, and section 3 goes to here, that 8 divided by 3 is going to be 2.67 meters. So the distance from one end to the first node is going to be 2.67 meters. And it's going to be the same distance between all of them. Now if we wanted to find the distance to the antinode, so from here to here, and we want to find that distance, well that's just the node distance divided by 2. So that value is going to be 2.67 divided by 2 gives me 1.33. So these antinodes are 1.33 each from each end, but if we look at the distance between them, that's also going to be 2.67 meters. Okay, so we have all of those values. Next we want to look at finding what the wavelength is and the frequency. Now we want to look at determining the wavelength and the frequency for this particular wave. So the wavelength is lambda, and we said we're working with the third harmonic, so that's 2 over 3 times our length is 8 meters, so 2/3 of 8 meters is 5.33 meters. And now we want to figure out what the frequency is. So we could go ahead and find the velocity is equal to f lambda and find the velocity that way, but we already have the equation with kind of velocity built in, so we'll do that. But first we need mu is equal to our mass over our length, gives us 0.04 kilograms divided by 8 meters, gives us a linear density of 0.005 kilograms per meter. And I can use that in this equation to find the third harmonic. Again, this was an n, we replaced it with 3. So I get 3 over 2 times 8 meters times my force is just given as a force, so that's 49 newtons divided by 0.005 kilograms per meter gives me a frequency of 18.6 hertz. So there's those values again. And now it's your turn to give it a try. What then would need to be the frequency for the fourth harmonic? So we can do it one of two ways. We could have figured out what the first harmonic was and then just multiplied by n, but we didn't do that, so it's almost easier just to put the numbers in. So here we have the fourth harmonic times 2 times the length equals times the square root of 49 newtons over that linear density that we just found. Gives us a value of now 24.7 hertz will be the next frequency.